David Lee?
or no, I don't.
Okay. And
David,
and
you have a number, don't you?
I have a few. I have 3.
No,
That's not what he means.
David Lee, you have a RASC D number, don't you?
The rest, yeah, I do. I can't remember it, but
You're a member of the club.
I'm
that's
a
its
member of the
private
Royal
branch.
Astronomical Society of Daves.
So
I
Dave,
just can't remember which one I am. So
you now qualify to be a member of that exclusive group.
that's true.
After you pass the initiation.
We should contact David Lane, actually.
Was he the one that started it?
I think he may have. I don't know. I'm not sure.
And would you have to go to a GA to gather it?
You
Because
do.
don't they have a private meeting?
Some kind of initiation.
It is a private. It's a very secretive private meeting. I can't tell you anything about it, obviously.
It's like the Masons.
Yeah, something like that. Well, maybe not that extreme.
Anyway, Dave Payne doesn't look like he's interested, so that's just as well.
I'm listening. I'm laughing.
Yeah, I think David's probably quite suspicious. It could be a trap.
Yeah.
Okay, seeing as I have a few imagers here, although David Payne might not be interested, Mark was talking about wanting to train some people on the camera setup that will be on the 25-inch. So that if there's any issues, he wouldn't have to be involved. Somebody else with technical abilities would just sort of maybe deal with things. Because he is going to just treat it as an astrograph, which it is, slap a camera on it, bolt it in place. And if they want to do visual, they have the 15-inch obsession and the 10-inch. They have other scopes. So they don't need to.
Do they have like a new CCD camera? I just can't remember what they have.
He was getting he bought another camera. So he has an ST2000, but I think that's on something and I don't know what else he has, but he was getting a new camera. He has a new camera, and some of the girls that were there last year, they fundraised a bunch of money. I don't know how, and bought him the latest Maxim DL and one of the other software programs, so that he can really just run, because he was having trouble making the old one work with the scopes and everything. And then he slapped this new one on and it all just meshed perfectly.
Yeah, I was actually surprised, like with the proliferation of all sorts of software. Maxim DL is still widely used, especially in the astrometry community. AAVSO, almost all their stuff is done on Maxim.
Yeah, so that's what he has. And so he is wanting to train some people on how to use it, and so that then they can use the full aperture and load up their memory sticks and take it away.
Are they?
And then if you left your stuff behind too on, well, if the info was still left on the computer also, so that the kids could do stuff with it too, to learn processing and stuff.
Are they likely to do kind of scientific observing as well?
That's what he's been doing with them.
He wants to do? Okay.
Well, because he always has. He likes them to do spectroscopy and stuff like that, so that then they can write papers. Because it's an activity, but then they can turn it into physics. So they can use it in their other classes.
Yeah, that's
and write a paper and do their extended essay or something like that. So a bunch of surveys, and he's done that over the years where they've been doing some surveys of stuff. Yeah. So he's always tried to mesh the science so that it is applicable to them. So some always like doing that.
Just before we get started, I want to ask, I have down on my list right now, I have Garry Sedun, Brock Johnston, David Payne, Dan Posey, myself, and Ken Atkinson. Did anybody else have something that he wanted to show tonight or would show tonight? Or anything you want to say? Okay, So we're up to 19 participants now. Let's just give it another minute or so and then we'll get started. Bill, if you want to show some sketches tonight, that would be fine too.
I haven't got any sketches.
Okay.
You've been doing observing though.
Okay.
Yeah, I have been doing some.
Yeah.
I've been playing with my scope, so some of it has just been testing out things.
Actually, I even got out and had another look at RS Ophiuchi. So doesn't look like it's really changed much in brightness, though everybody says it's like a Mag 6. But when I looked at it a couple of days ago, it was still looking at a fairly strong 5 actually.
Mhm.
Maybe a 5.5, but I thought it was still like a 5.
What are you using with the moon up like it is?
Yeah, the moon was quite close. That's the only catch. I'm hoping tonight to look again because it's supposed to be clear tonight.
Okay, well, welcome everybody. Welcome to Astronomy Cafe. And I hope you enjoy it tonight. We're going to start off with something that we've done in the past, but we haven't done quite so much recently, and that's have some of our local Victoria area astrophotographers show some of the things that they're interested. And from a slightly different point of view, let me just start by saying that for those of us that get into this, we all know we can go on the internet and get amazing pictures that Hubble has done and so on. But the real thrill of doing astrophotography is getting your own picture, even if it's not as good as somebody else's. And it doesn't have to be great. You have to think about the fact that you're collecting photons through your instrument and they're coming in as you take the data and you get to make a picture from it. And that's really kind of exciting and kind of fun. So some of the local astrophotographers are going to tell you some of the things they've looked at and why they've done it. And some of these will be very recent images and some maybe not so recent. So before I say any more, is there anyone other than Garry, Brock, David Payne, Dan Posey, and myself, and Ken Atkinson that have something they want to do? Okay, in that case, we'll get started. So Garry Sedun, you are first one on the list. Go
Hang
ahead
on
and do your thing.
hang on for a second here. I just got off the phone with our grandson who decided he wanted to have a 40-minute conversation via Zoom. And that's what I was supposed to be putting my list together. So I'll be last, please, if you don't mind.
Okay, I'll put you down the list. Brock, would
Okay.
you like to go next?
Sure, I'll share some pictures here. Just a moment. Can you guys see anything?
Yes, it's there,
Cocoon.
Brock.
Okay. Yeah, this I just went back a month and a bit. I didn't go back too far because I've shown a few things, but the Cocoon Nebula was actually one of the first images that I got with my new one-shot color camera. But I don't have any filters for it yet. I ordered filters, but as you know, you order things and you just sort of sit around and keep using the stuff you have. But I got this image back in June or early July, I guess. And then I realized without filters, I was probably better off hitting some galactic targets. So then I went on to hit the fireworks galaxy. And that actually worked. I was pretty happy with that one. And of course, with the one-shot color camera, I got really nice picking up the red nebula regions in the galaxy quite nicely. And then of course, once after doing that one, I kind of wanted to hit the the mother of all galaxy shots. So I went and got out my wider field telescope and took some shots of Andromeda. I did actually 3 nights, and the first couple didn't work out as well. I needed just that little extra night of data to get some of the fainter regions to really jump. So
Beautiful.
and I was pretty happy with this one. The other ones were just kind of one night, just kind of set it up, go to bed. But this one was several nights, and spent a bit more time messing with it. But
Brock, is this with the ASCAR that you have?
yeah, this is with the ASCAR.
Yeah.
Just straight up, no filters, just the ASCAR, and reasonably not a lot of moonlight. So just out in the backyard.
Oh, very nice.
So I
That's
was pretty happy.
The one-shot color camera?
Yes.
Wow.
What's the focal length on that, Brock?
It's 400.
Okay.
And it has a reducer, but this isn't with the reducer. The reducer takes it to 285. I think.
So this is 285. Wow.
No, this is with the 400
This is the
without
400.
the reducer.
Okay.
So
Brock,
Is it? Sorry, go ahead.
I was just going to ask Brock, what goes into your choice of subjects when you go after things?
well, a lot of it is, I mean, there's some extent of just stuff I haven't done before. And I tend to scan the sky in the east so that I know I'm going to grab something that's going to go up and over and, be in the highest part of the sky overnight. So, I don't want to grab stuff that's kind of already setting in the west, because I'll end up with more gradients and I won't have as much time.
Mhm.
So I kind of pick that part of the sky where I know it's kind of ascending and it's going to, go up and stay up nice and high throughout the night. And then I just kind of go for stuff that I'm interested in, what looks really nice. And then I know, in this case, it's stuff I know I have the equipment for, because my dual narrowband filter isn't in my hands yet. So going after, I did a couple of nebula shots without it, and I was like, yeah, that's just not, this is not good. So they're just a mess. But I'm looking forward to getting that filter, and then I can actually do another shot of Andromeda too, and get some more pop out of the red nebulosity. So,
Brock, why did you omit the reducer?
well, I didn't need it to get the field of view, and I figured the less glass in between me and the object, the better.
Okay.
And it's already like I don't need the speed. This is f5.6, so the reducer just would have given me a lot more stuff to crop out of the image.
Yeah, good point.
So,
How do you like the 2600 there?
it's seems really good. I like it a lot. The noise
Yeah.
is pretty much zero, and there's no amp glow. Dave was nice enough to lend me his 1600, and it was great. I really enjoyed using some narrowband with the mono, but there definitely is amp glow in that, and not having any amp glow at all was pretty amazing.
Yeah.
Yeah, I have the same camera, Ken, and I love it too.
Oh, your pictures are just absolutely amazing, Dave.
Oh, thank you.
I haven't been writing any comments, but you blow me away every time.
Yeah, if Dave shows his Andromeda, I'll just kind of shrink in
Yeah,
the corner.
you too, Brock.
The next one I did was a much more distant one. This was with my Edge 925, and this is actually cropped way into like this Deerlick. This is the Deerlick group, I think it's called.
Mhm.
And there's one more prominent galaxy, and then I don't know if these are all close together, and some of them are small and some of them are big, or if they're really distant. I didn't do the research, but there's a ton of galaxies in the shot. There's like one here, there's a whole bunch over here, there's one down in the corner, and of course the more prominent one in the center.
Is this also Caldwell C30?
Good question. I don't know. I'd have to Google it.
Oh, okay. I've been chasing that one for ages.
Oh yeah.
Brock, can you tell me what size sensor that camera has?
It's an APS-C.
It is APS-C, okay.
Yeah, but it's a big APS-C. Like I have a Canon T3i that I modified, and this thing really has a noticeably bigger field of view than the Canon version of the APS-Cs.
Yeah, Brock, I think the Canon APS-Cs are a little bit smaller. I think they're like a 1.6 and the more traditional ones are 1.5.
Brock, you haven't been doing astrophotography for a very long time, have you?
No, I bought my telescope. I mean, I had an old Dobsonian. I took a couple pictures of Saturn, and I got my pictures of, like, you know, the Venus transit and stuff, but I wasn't able to do really much with that thing. So then this, in sort of, I guess September, late September, I ordered my Celestron Edge 925 from Ken in Alberta, and managed to get something decent. So
for those of us that spent years trying to learn how to do this, it's really quite startling to see how people like you and Dave Payne have just come on like gangbusters.
Yeah, good for you guys.
well, the
Very well.
technology, I think I'm cheating with some of the technology, but you guys started out with less.
Yeah.
I'll take that.
That's true
Yeah.
though.
You're being too kind.
Then it's been really, you know, the moon got bigger and bigger, and I was kind of like, oh, I don't really want to go and fight the moonlight. And I went out for 3 or 4 nights in a row, and I was trying to get Jupiter and Saturn, and the seeing was just atrocious. And I just came back with, you know, gigabytes of video, and just spent hours looking at big smudgy, blotchy messes. And then so one night on, I guess it was the 19th, I went out, and the seeing was dramatically better. So I got some nice shots of Jupiter, and I messed around a little bit. This actual one here was a bit of I went back and kind of revisited my data, and I trimmed it down because I was doing 3-minute exposures. And actually I have a little GIF here that helps to illustrate the problem. This GIF here, this is 3 or 4 images taken 10 minutes apart.
Mhm.
And so you can see that's basically, each frame is about 10 minutes. So by doing even 3-minute exposures, Jupiter is actually moving
Quite a bit, yeah.
quite a bit. And so I went back, I actually posted a picture of my Jupiter shot. Where is that? There it is. Is it this one? No, sorry. I accidentally opened another window. So I posted a picture of my Jupiter shot, and then I went back, and of the 3 minutes, I actually took it and used pip to cut just so I'd have the very last minute and 20 seconds. And then I reprocessed that shorter period of time, and it actually sharpened it up a lot. I got a lot more, like these spots here came out, the little lighter storms down here popped up a little bit better. So I realized really sticking with Jupiter, about a minute's about as much as you really want to do, or else it really starts smearing, and it's hard to get that.
How long's a day, Brock?
8 hours.
8 hours.
So it's about I did the math, it's like 2 degrees a minute or something, I don't remember, but it's a significant amount that moves. So
Well, think of how much an image would move if you just put your camera on something and left it for 3 minutes on Earth.
oh yeah, for sure.
And it's spinning way faster.
It's spinning really fast. It's funny, if you actually go into Photoshop and you draw a perfect circle over this thing, I should have done that, but it's amazing how
It's
bulgy it is.
stretched.
Like it's
Yeah,
super oval.
Yeah, it
It's
bulges a
spinning
lot.
so fast.
Mhm.
So I did that, and
You used a planetary camera for this?
yeah, I used just a really cheapo 120 MCS because it's got a tiny sensor, but who cares? Because it's still a huge sensor compared to the image of Jupiter. So
But it
That's
is
the same one I use.
yeah, but it is one shot, is it, Brock?
it's a one-shot color, yeah.
Yeah.
And
Oh.
I didn't want to fuck around with filters to take pictures of Jupiter.
Yeah.
I have
So
the
it
same
was
one,
like
but
$150 or something, and I was just like, that's enough for this.
I have the mono version, which is very similar.
Oh yeah, exactly. So, and then I did one, this is one I tried the derotating, but in fact, this previous one is the one, the derotation was done with 3 or 4 3-minute exposures. And actually the single frame of the shorter exposure time turned out better than the derotated one. So
Brock, when you did the derotation, did you derotate the actual video or just the separate processed frames after?
Just the separate processed frames.
Okay.
So I might
Did you-
mess with the video too, but
Yeah, okay. I haven't done that either. I just wondered.
yeah. And then the final shot was Jupiter, or sorry, Saturn.
Nice.
The little animations in there, and I got the same night. I just kind of kept going back and forth between. I'd get 3 minutes of Saturn, and then go back to Jupiter and get 3 minutes of Jupiter, and I just kept doing that until I created an enormous, ridiculous amount of data, and then went
So
back.
Brock, what would the speed of change be on Saturn as opposed to Jupiter?
I think Saturn's way slower.
It is.
I don't remember, but does anyone remember?
I don't remember the numbers, but I know you can shoot in a fairly leisurely manner on Saturn. Jupiter, you just really have to rush it.
John, have you used WinJupos for video?
No, I've thought about it. The reason I asked you is that that's the next thing I want to try, and I didn't know if you might have done it already.
Yeah, I haven't. I've watched a few videos by some pretty accomplished planetary guys, and they generally do the same process. Like they'll actually do the sort of registacks or auto stacker registacks, and then they'll use those images and derotate them. So I don't know if WinJupos deals well with the sort of bouncing around seeing issues. That I'm not sure exactly how that might play out.
I don't know either.
Yeah.
Saturn's apparently 10.2 hours, but
is it?
It's also much farther away, which means that the angle should be smaller.
Brock, I think if you have problems with it jumping around too much, you can use a PIP.
Stabilize it in PIP and then use WinJupos.
Okay, because I think it centers it for you.
Yeah, well, yeah, it totally does. That's a great idea. I didn't think of that. But yeah, PIP is a really good one for that because it just blocks it in perfectly in the center of the frame.
Yeah, exactly.
And and then you could also sort it. You could do the PIP sort by quality, and then just take the top 30% and then process that in WinJupos. Yeah, I might try that.
What's the PIP?
PIP is.
Yeah, go ahead, Brock.
No, you go.
Okay, yeah. So PIP is Ken is a piece of software that is used mainly to sort of I guess kind of true up video, because video tends to be just like Brock was saying, if it's jumping all over the place, it will actually center the object. Like it'll find the object, find the centroid, and then center it, and then do a cookie cut, and then give you a bunch of frames that are all centered. It does other things as well. It does kind of, and it's free. Yeah.
It also worked. I used it to I had this 3-minute video and I just wanted the last minute. And it was really easy to do that too. I could just say, take frame 4,000 to frame 8,000 or whatever, and output it in a different file.
Yeah. Video processor. That's what it is. That's what I think of it as being.
Yeah. Okay. And it also was good for if you're using a DSLR to do your video rather than a one-shot color. It can turn like DSLR.mov or whatever files come out of the compressed DSLR files, which you can't directly put into AutoStacker. Yeah. You can then convert that compressed video into an uncompressed video and then bring it into AutoStacker. But of course, compression just kills your detail. That's why I spent 150 on that ASI planetary camera, because I was pretty frustrated with my DSLR last year. So.
Well, Brock, that's really beautiful work.
Thanks. That's all I have. Well, I have more, but that's what I decided to show tonight. So.
Okay. So Dave Payne, would you like to go next?
Sure. I have brought you a bouquet of flowers.
Oh.
Because I'm a romantic guy. So the first flower is they're all 3-art. Why is my screen flashing? Is it okay for you guys?
A rose, yeah, that's beautiful.
Yeah, we're getting a flash too, though. It's weird.
Oops, it disappeared again, Dave.
Oh, there we go. Can you see it?
No.
We could before.
But it was flashing.
There. Whoops.
Oops.
I want to share my screen. There. Have you got it
That's
now?
it.
Yep.
Yep.
Okay,
It's there.
so sorry about that. So it's the Rosette Nebula in Monoceros. It's an emission nebula, and it's one I wanted to show because I took it going on a year ago, maybe about 10 months ago anyways. It's not a bad picture. I think my processing has been helped by a lot of people around that, a lot of you guys in your comments and particularly your constructive criticism and suggestions from a lot of you, you know, John, Gary, Joe, Brock and David, and hopefully I'm not leaving anybody out, but they've been very, very helpful. But this is about, it's actually a very interesting object. It's hard to see with the eye because it's generally red. It's part of a large hydrogen H2 cloud in the area. And this H2 cloud is actually created in the past, has created a star cluster in the middle of it. And when these stars, young stars, have energized, they are sending a lot of, they're sending a lot of energy out to the cloud, and that's heating the cloud up to about 6 million Kelvin. So I just find that so fantastically hot. The UV, it's also putting out a lot of UV radiation that's being absorbed by the hydrogen, and then that's making the hydrogen or the nebula actually light up. And we see it. So this is about 5 full moons across, about 1 degree across. It's about 5,200 light years away. It was taken with and about 30 light years across. And it was taken with my refractor 127, which has a 660 millimeter focal length.
Did you reprocess this one, David? Is that like you took your data from before and redid it, or
no?
Is
No,
this the original?
This is how this was the original processing 10 months ago.
Okay, looks pretty darn good.
Very
Well,
good.
thank
You
you.
were saying how you've improved. Now it's like
Well,
I'd like to see you redo it.
that's one of my oh, where's my oh, here it is. What's behind you guys? So then I'd like to turn to one of the more recent ones.
This is up in Orion, isn't it?
That's in Monoceros, next to Orion. Yeah.
Okay.
Just kind of up and to the left.
Yeah, up and to the left, but it's in that same general area.
Oh, where'd that go? I'm losing stuff all over the place. Oh, I'm just gonna make full screen.
That's
Okay,
better.
can we see that?
Yes.
So that is a similar molecular cloud. This time it's a tulip, although it's upside down here. But it's called the Tulip Nebula. It's one of the Sharpless entries in the Sharpless catalog. It is about 6,000 light years away, so it's just about the same distance away as the Rosette that I showed previously. But it's quite a bit smaller. This is 70 light years across. And this was taken with the CDK 12.5 inch, which is 25-40 millimeter, so a lot longer focal length. Both this and the previous one we're taking in narrowband. It's again an emission nebula, and it's being powered by this star here, I believe, that is sort of blowing these gusts, blowing the H2 away from its location, the same time lighting it up. And you see all these nice little petals in there. So it's the same thing. I think it's processed much better than the Rosette. I can see a lot more detail. I can see you know, the streamers off this side of gases being blown into the interstellar media out here. The other interesting thing, and I'm not sure if you can see this or not, but right on the left-hand side of this frame, there's a bit of a purple arc
Yes,
that you can see.
yes, we can see it.
Right here, I believe, is Cygnus X1. So which you probably heard of. It's one of the brightest X-ray sources in the night sky. And somewhere in the vicinity is a black hole. And that purple little arc that you see there is, I am told, is driven by jets from the black hole accretion disk. So I thought that was very interesting of this image. So I want to go back here and maybe focus in on this and see what I can draw out. I know I won't take a picture of a black hole, but anyways, we're going to find out. But I think this is much better processed, and I you know, I want to thank everyone around the room for helping me with this development.
Beautifully done.
Yeah, it's really nice.
Skills. And then I finally got one last flower to show you. It's a different kind of flower. Both this and the previous one are mainly hydrogen. Oops, sorry. Go back here. And in contrast, the last flower I have is the Iris Nebula. So this is very different. This is much closer. It's only 1,300 light years away. So it's only roughly 1/6 the distance, 1/5 the distance away. And rather than, there is a little bit of shining, you can see a little bit of red here and there, and that is, again, emission, but it's really dominated by the color blue. And dust, when it has a starlight reflecting off of it, so it's a reflecting nebula, shows blue. And the star that's powering most of this reflection is dead center in the iris there. So and it also contains a lot of dark nebula around it, which is actually the same as the reflective nebula, except it doesn't have any light bouncing off of it. And instead, what you see it does is actually blots out the stars behind it.
Then you can also see sort of grayish stuff that is probably dust that is a little bit reflecting, but not much.
Yes, out on the outer edges.
Yeah, it's a beautiful picture.
That is
I
really
love this nebula. It is so fine.
I love the dark matter in that, or the dark dust in that. It gives it a sense of depth.
Mm-hmm.
Yeah.
Yeah, this is an exceedingly hard object to image. It's quite faint.
I've tried. I agree. I didn't show mine for good reason.
The other, just one last tidbit of interesting thing. It may contain someone's analyzed the spectrum here and said it's called something called some organic molecules that are called PAHs, and I don't know what PAHs are.
PAHs.
And that has some significance.
Polyaromatic hydrocarbons.
Okay. So is that
my wife's an expert in those?
okay? I don't know why, other than being a hydrocarbon, why those are they special somehow? Do you know? Or
Well, aromatics would be rings. They'd be like benzene rings and stuff.
Yeah.
So like poly, sort of like
It's the same kind of thing that that can life grows out of those kind of carbon ring things. So when they see this stuff, it's kind of a marker that there are some of the chemicals in space that life can grow out of. So that makes them quite exciting.
Right.
Okay. So it's not just benzene and toluene and xylene.
Yep. Yeah.
Dave,
Okay.
one question I have is, I've noticed in a number of the pictures that you've shown here and elsewhere, you seem to have a real focus on being interested in the physical and chemical processes that are going on inside. And that appeals to me too. So that's interesting.
Yeah, it's exploring with the camera, right?
Mhm.
It is.
Okay,
That's really
thank you.
Thanks very much, Dave.
Thanks.
Jan Posey, would you like to go next?
Sure, just had to find the mute button. Hello, everybody. It's been a while since I've actually made it out to an Astro Cafe. I've had schedule conflicts for years that never quite allowed me to get out on Monday nights, but softball and the other meetings have all ended, so I can actually make it out this week, and it's nice to be here.
Good to see you here.
Let me just grab my screen here. I'll go on a bit of a whirlwind tour, and I don't know what these are going to get stacked up on. So part of this came out of a quick presentation we gave on Saturday night. And one of the things that I realized when I was showing photos is that a lot of my astrophotography journey has almost been in reverse, where I started out, I guess I was in second year or something, university. And I don't know if it's quite true that Dave and Brock and the new guys have come in at the right time, because I definitely did, where there was this transition that had maybe only happened a year or two ahead of me that allowed things to happen with DSLRs that could be used to take reasonable photos. And I jumped in, I heard the description of how you take photos of the night sky, and I was ready to go. But I started off with really long focal length work, and then I steadily moved back. And over the last year, I haven't had much of a chance to, or year or two, I haven't had much of a chance to get out and do long nights anymore, because there's this unfortunate thing where you apparently have to be awake to go to work the next morning. And, you know, who knew, right? So I started out with this photo of Rho Fuchs that I took last summer, just as an example of what can be done with the right kind of small, short focal length kit in quick succession. And this one has been a lot of fun. So I thought I'd start with a few of the photos out of that setup, just to give an idea of what can be done with a camera lens, a modified but a DSLR, and a little tracker, because I've been doing that purely to kind of cheat my way through imaging for the last little bit, because I realized that if all you're trying to do is to get enough information in each frame, sometimes camera lenses are a better way to get there than telescopes. And so in this case, I'm using a 105mm lens, but it has an f1.4 aperture, which means that it's about the size of a small telescope. It's just shooting a really big field. And so you get all this information all at once, and you're still getting 75mm of aperture on it. Where you pay the penalty is that if you zoom in, you start to eventually run out of resolution when you do it. But what it allows you to do is to pick up all this kind of background material, which also introduced me to a new type of imaging that I didn't really think too long or hard about in the past, which was that, did you know that apparently space is not very clean? It's very dusty up there. So I started to run down the path of digging into some of that stuff, which then informed how I picked a telescope to complement this. So this is, I think, the last photo off of that little tracker camera setup. And the beauty of these, I think the last Orion shot was 2 hours. This shot here is only, I think, 38 minutes or something like that. And it does a great job. It's really not cropped too much, and you can explore really wide vistas of the night sky. So it's kind of quick and dirty run and gun imaging, but it's also really neat because a slightly tweaked version of that same kit is incredibly accessible. I think that there's a f2 lens from Rokinon and Samyang that is 135mm instead of 105, and it's $600 or something, and it will do 95% of the work of this, if not more. So it's a really cool way to get into all this without breaking the bank. But I decided to break the bank. So I did get a new telescope last year, and I went with that same philosophy. It's actually the same brand that Brock has, ASCAR, and I have the slightly larger 600 millimeter focal length version, which is a bit of a truck. I think it weighs 20 pounds. It's a 108 mil refractor. It's not exactly the lightest thing in the world, but it has a nice focal reducer that allows me to get it down to f3.85 or so. And so this image of the California nebula was shot from the VCO using one of those tri-band light pollution filters, but it did a pretty good job for just being around 2 hours of data.
Wow.
And that's because, again, high efficiency imaging is the name of my game recently, and it allows me to get to bed at a semi-decent hour.
That's
really
one
have
of the
a-
more sort of three-dimensional looking California nebulas
Yeah.
I've seen.
Yeah, exactly.
It often
Oh.
just looks like this big kind of red thing, but there's a depth to that. It's pretty
That was
amazing.
beautiful.
And I forgot, this is one more from that 105 mil. So this is just, I think, 2 or 3 minutes off a tracker of the comet when it went by. And all these horizontal streaks going through with the clouds that I was having to shoot through because I made a lot of user errors when the comet was here. And most of them weren't forgivable or excusable, given that that was the 1 week where I decided, work can wait. It's a once in a 20-year comet. And so I was up at 3 or 4 in the morning a few nights in a row trying to get a real crack at this thing, and then getting laughed at in meetings the next day as I was slumbering over my coffee. But again, just to give an idea of how much fine detail you can pull out with the right setup in short amounts of time, it's
Did you take the stars out and put them back in?
yeah, usually I use StarNet. I don't know if I did for that one.
Okay.
But I've been doing a lot of StarNet work, and it works better. The wider your field is, the better StarNet works.
Yeah.
So if you're doing long focal length work, it tends to stumble over itself. And if everybody doesn't know, StarNet's a neural net that they program that can work either off of a CPU or a GPU. And so for the imagers here, I've got a tutorial if you ever want to break your system to allow you to use an NVIDIA GPU. Instead, I can do a very aggressive StarNet separation in a couple minutes with my big card, which takes all the load off the CPU. But that refractor that I mentioned also allowed some quite neat broadband work. And so this was shot again up at the VCO, and I think it's only, again, a couple hours, but I was able to pull out some of the deep background intergalactic flux or integrated flux nebula, which is a feature of the Milky Way, but it's one that was only recently discovered. I think it only was coined as a term in about 2003. And it's because up until recently, professionals didn't really tend to point their big expensive telescopes at dark patches of the sky to see if something was there, other than the Hubble Deep Field and the Ultra Deep Field and those efforts.
Hey, Dan,
so, yeah.
how did you get the whatever it is, gas, and not saturate the galaxies? Did you use a lot of masks during processing, or what?
A little bit. So this one, I definitely would have pulled the stars out, which allow, and so the reason why you pull stars out is that you can stretch the frame, and then you're able to stop when the stars look good. And you can actually see some of the artifacts here from that neural net. It's not perfect, and it will leave some marks behind.
Yeah.
But if you pull the stars out and then you add them back in, you can add them back in when they're not too bright, which allows your bigger pieces to show. And so I think for this one, what I did was I pulled the stars, I let the galaxies go, and then I worked to bring out the background material. And then after that, I had to do some very careful HDR work using the HDR tools to bring the galaxies back. And the trick I've found is that you don't use it at the default setting. You go up to usually 8 layers or 9 layers, which takes much more gentle slopes of how it's going to pull the information back. And, there's a little bit of damage from the HDR work in the center here, but you still get some of the internal structure coming through quite nicely. 2 hours isn't enough to have put the galaxies at this color level, so they're falling apart, but you can't tell from out here.
Just another trick to do with that, Dan, is if I find the HDR, the number of wavelengths that I want to use, then I do the HDR on one lower, one higher than that one.
Okay.
And it's kind of what level of detail you want to bring out, like how big is the galaxy is really what determines that number. And then I pixel math average them. And I might even average it back into the original image. And then you've got that fine adjustment of that process that normally it's like using a brick.
It's
right?
true. It is.
And-
That's actually a really good approach. I do that with a couple other things, but I hadn't thought about doing it with the HDR side. I usually will average out noise reduction and a few other pieces along the way. So anyway, this has been the latest in the journey, is to image at that, f3, f4 focal ratio to go quickly. And then I got cooped up inside for most of the year with COVID being a thing. And so I decided to see what you could do from a balcony downtown, because when you have idle time and idle hands and want to sleep in a bed while you're imaging, things don't always give you that much room. So this one I just shot last week, I think, off the balcony out there, and it's the Eagle Nebula, and it's showing some flaws. There's not enough signal in the background, and I've run out of resolution in the core. At 400 millimeter focal length, you can't do much to it, and I'm using an old camera, so it doesn't have the greatest quality, but I didn't ever think I'd be able to do something like this downtown, and this is a testament to both the kinds of processing tutorials you can follow online and to narrowband filters, which I know they've been around for a long time, but I'm just wading my toes into it, and it's quite a bit of fun.
So
And
which
I thought
camera was this, Dan? You said it was an old.
SBIG 8300. So not the greatest camera in the world to work with for narrowband, but I managed to hide most of the issues because all the light pollution actually swamps the read noise issues with the camera and lets me get away with it. So if I tried to shoot narrowband from a better location like the VCO, my pictures would probably look worse, paradoxically. But I thought I'd just show, for an example, I think the best shot of this pillars region that I had came from that old 16-inch that we briefly had at the VCO. And so I didn't quite get up to the same kind of resolution, but you can still see most of the same structures in here, despite that. So, and then finally, just to avoid running out of time here, I thought I'd share something more akin to where my journey began, which is a long focal length shot. This one was off the Plaskett. It's NGC 7318, which is a ARP 214. It's interacting galaxy pair. But I wanted to mention this one because it looks like I may have secured us 2 nights on the Plaskett this fall. Tentatively, one on the new moon in October and one on the early new moon in December. So just to share with everybody what that would mean, we can't go up and use the control room like we normally would, where we would have an imaging party go up of the active observers. But think about interesting objects that you might like either a single frame photo of, or if there are a lot of votes in a direction, then I'll try and create a big group image project like I did for this one and create a color image for the night. Again, provided it's clear, no, all bets are off on that. But I just wanted to shout that out there to everybody, that there might be an opportunity to, if we're lucky, get some imaging time on the Plaskett again, which has been a little bit over a year. And figured I'd end on this to hopefully have some excited options out there for October. And then, although the odds are worse for December if it's clear. And this is a false color.
Day.
This one's just for everybody's reference. It's a false color image. It's the Sloan Digital Sky Survey filter set. So I had to map green to blue, red to green, and infrared, or near infrared to red. So you can get away with that on galaxies and other black body emission targets, but you can't really get away with it on emission nebula. So if that helps you pick targets, all the better.
Is that the cat's eye, Dan?
No, that's a galaxy.
It's a galaxy. Yeah, it's ARP 214.
Oh, okay.
Have you tried the cat's eye, Dave? That I've been wanting to try that. It looks really, really faint, but
I went to it and it was really tiny.
yeah, it looks tiny and faint. And it's like,
But I guess if there's one thing I'd end on is I've had just as much fun over the last year going with wide focal length as I ever did with long focal length stuff, and you'll always find something interesting to do. So whatever equipment you have, there's never been a better time to hop into this, and there's just the most wonderful group of knowledgeable rascals to help you out along the way. So yeah, thank you.
Dan, you made a quick start also when you started imaging. You went from knowing very little to knowing a whole lot very quickly. And
Well,
you seem to be continuing to do that. I like your wide field stuff too, very much.
thank you. Well, I appreciate your patience with me when I took you over to show you my telescope and you looked at me taking deep sky stuff with an alt azimuth setup, and you didn't just shake your head and walk away. So if anybody doesn't know, I started out doing everything as wrong as you could, but there's nothing if not a lot to learn, and it's a really fun hobby to take along the way. And we have a great facility up on the hill where you can come up and learn and enjoy it at your own pace. So yeah, it's been a decade of fun.
Something that some of you might find interesting just from the history of this. Joe will know about it, but not very many of the others. Chris Gaynor might know. But when we first started doing imaging with DSLRs, Charles Banville was here at that time. Bruno Quenneville was doing it. David Lee, Joe Carr. I was learning from those guys. But there was a sense in which we felt if we helped each other, we would all get better at this. And it was a real kind of community activity. And that's what I'm kind of hoping comes out of having nights like this where we show our stuff and talk about it with a little more depth than just showing the pictures. So I hope that helps. Anyway, thanks very much, Dan. That was great.
Yeah, thanks, John.
So next is Garry Sedun. Are you ready, Garry?
Yep, I'm as ready as I ever will be, I guess.
Okay.
First of all, I have to echo what John just said. Like, I'm going to be giving Dave a call about your pixel math thing with your whatever you said you were doing there. Like, good for you. So, I'm very happy to see such a humble bunch of imagers, because that way I can show some of my less than stellar images and you'll completely understand, right? So let's just go here. Okay, first what I'm going to do is I'm going to show you my very first image I ever took with a Astrocam camera. I just have to find it first. Okay, hang on. Change it. How do you share the screen so you can change images?
Just do a share the screen. You'll see the screen up there. Share that rather than an individual file.
Okay, okay, there. You can see the Horsehead Nebula there?
Can't see anything yet. You got to say share it.
Yeah, okay, fine. Okay, you can shoot.
Now we can.
Okay, right, there you go.
That's the Horsehead, yeah.
Yeah, so this is the first astro image I ever took. And
wow.
It's pretty nice.
Good.
Yeah, I was surprised about it. And this was one where I actually took it with an old monochrome 2000 XM camera. And I remember processing it with something called, what was it? A free program of some sort. I forget what it was.
Deep Sky Stacker?
Yeah, no, not Deep Sky, but anyhow, one that's free. And man, it took me like a month to get here. Like, holy smokes. And, you know, I'm glad I'm talking to a bunch of imagers. This is actually very nice to be talking to primarily the imagers of the crowd, you know, because we all can see things that are wrong with our images. Like, look, can you see my cursor on this one? Like, all the stars are the same color, you know, not too cool. But I guess my approach back then was, how hard can it be? Well, you know what? It turned out to be really, really hard. Like why on earth did I try and go for 2400 millimeter focal length for my first image? I don't know. But this kind of worked out. I'm pretty happy with this for a first image.
So one
You
interesting
defied
thing,
the
Gary,
odds, Gary, because usually people that dive in that deep, we only see them once and then they're gone.
Yeah.
I guess I'm stubborn.
You're a lot more stubborn than most, I think.
I think so.
Gary, I'd be happy to be bagging this one any night. That's a killer image. Look at the detail on the head.
So one thing, when I take this, the horse head is just black. And then I've seen on the internet, I see the clouds in yours on the actual horse head.
Yeah.
And they say the pictures they say this is what you see when you capture infrared light.
I have no idea why I see clouds there.
There is some of it. You're right, Dave. There is some of it in the near infrared, but I think that you also see a touch like up at the top that Gary's captured with just really deep natural light images too.
Yeah, this is strictly RGB.
Yeah, it's fantastic.
It's crazy.
And here's another one from that very same camera. Did that change? Did it change to M51?
Yep.
Mhm.
Good. And this is, I don't know if this is overexposed or not, but I don't know if I really like all this dust hanging around out here, you know, like kind of makes it a bit messy. But John McDonald was down there when I was doing this one, and he said, this looks great. And I said, okay, if you say so. But I think if I was going to be doing it again, I wouldn't try and get all this dust in there. It's
But
pretty
it's there.
What's that?
It's there.
It is there.
I don't know if that's dust. Those could actually be stars.
Yeah, I think
Stars.
It's a galaxy.
it's an emerging galaxy. Yeah.
It is
Yeah, those are
stars that are,
stars.
that
Yeah.
are pulled out by the tidal forces.
Yeah, it's
Right.
that all that tidal interaction. Yeah.
Yeah,
So is it-
I love this
I'll get
galaxy.
there
I'm
in
gonna go
two.
back to it pretty soon.
So
And
is this with your 20-inch?
This is with the 20-inch.
Yeah, that's why there's the detail.
What's
Yeah.
that?
That's why there's the detail like in the horse head, because
Oh.
it's 20 inches of aperture.
Mhm.
Oh, okay.
Yeah, I
That
agree.
helps,
Yeah.
for sure.
Yeah.
Oh, it's
Yeah,
totally
Don't,
what it
don't
is.
throw away the data, whatever you do.
No,
You
I-
took your first picture with a 20-inch. That's
Yeah,
quite the.
yeah.
It's an
Yeah, and
F4
they're-
Newtonian, right?
I didn't know any better, you know. I didn't know.
He can tell you the story sometime. It's very interesting.
And it's a
Yeah.
fast scope too. It's
Well, it would
F4,
be, yeah.
right?
It's
It's
2500.
yeah, it's
It's 20
F4,
inches.
that's right. Yeah.
So
Wow.
It's
so
a
also
Newtonian astrograph. Yeah.
Well, you know what I did? I actually phoned up Bill. What's his name? Newton.
Jack?
Jack.
Jack Newton. Yeah, Jack Newton. I said, Bill. I mean, Jack, tell me all about what kind of scope I should be getting. And he says, well, let me start the timer so I can charge you for this. And that was the end of somebody telling me what I should do. You know, you have, when there's nobody around, you kind of have to just figure it out yourself. And it was more providence of me getting these two scopes and pieces more than anything else. But anyhow, moving along to a real camera now is M82. Now the technical details on this, since I was talking to my grandson instead of getting technical details, is this is a galaxy far, far away with a lot of stars in it. And that's about all I can tell you right now. But I love the jet. Like the jet just rocks, you know, like my goodness me. You show people this and they say you're kidding. And then when you show them how big, how big this thing is in reality compared to how big our solar system is, they just can't believe it. So it's an awesome, awesome thing to look at. I love it. I love it. I love it. And then there's, of course, the jellyfish, which I really, really like. Like some of the fine detail in here is just lovely. But you know what? Watching Dan, Posey, and Dave and Brock do their thing, and John, of course, I realized, look at all the stars. They're all the same color. So I'm really working on trying to get the right star color here, you know, kind of showing you my insecurities here. And especially with a tip from Dan about using the arcsine stretch function as opposed to just kind of blasting your way through from linear to nonlinear. So this needs a lot of work. But what's fascinating here for me is the beautiful detail over in the corner here. Like, whoa, that is just awesome. You know, like seriously, it's just amazing.
Gary, every single one of your shots goes so incredibly deep. I'm amazed that you actually have any star color to recover, given that you're like one of the funny things about aperture is that the size of your aperture is all that matters for stars. So your stars are going to saturate
Yeah.
probably
right?
4 or 5 times as fast as ours because you have a 20-inch mirror, because all of it's getting focused onto one point. So I'm actually shocked you have so much color in your stars, given the tube you're imaging with.
Well, thank you.
Yeah,
I
well,
feel better.
don't forget about the site as well and the conditions. You know, they're southern Arizona, pretty pristine
Yeah, it's pretty
in the
pristine.
middle of ranch land.
Yeah, right. It is. But you know what? The resolution is still only 2.5 to 3 arc seconds. So I'm not a very happy camper there. Neither a lot of other astronomers down there. They're starting to now move away to New Mexico in the middle of nowhere and spend a fortune on their gear just to get another couple arc seconds, which I didn't really think was a good idea. But that's it's their problem, not mine. And then here's a cool one. Going from here to here, this is really cool. I think I did this in PixInsight. Now you said, Dan, that you use a different tool, StarNet or something?
You know, it's in PixInsight. But it does it using a neural net. So it's an AI-driven process where it's all done automatically.
Yeah.
It was put together in PixInsight originally, I think.
Yeah. It's simply fabulous how this works, you know? Fabulous, fabulous. And then finally, one of my all-time favorites, like I just love M81. Like it looks good, you know? It looks
gorgeous.
Yeah, and I have 2 versions here. I've got this is the overdone version with the blown out stars, and just so I could see this blue bit up here, you don't see that very often, you know. But there it is. It's some bit of blue, and here's the less blown out one. But once again, hell of a time getting the dust lanes in the middle here, and these 2 stars here, mamma mia! Like, come on. Try and get those under control, just about impossible. I was trying masks, and I was trying this and that and all that other kind of stuff, but you know what, it just didn't work out. So this was what I finally had to live with, but it's still fine, you know, it's still fine, nothing wrong with it.
Beautiful.
So, yeah, it is beautiful, thank you. So I finally, at the end of just before COVID started, I finally got an offset mirror on this scope to let me get round stars. So I can't wait to get down there and start seeing what kind of data I can get that actually has nice round stars. Hopefully it's going to improve a little bit, that's for sure. There you go.
So that little blue section, that's a dwarf galaxy of M81.
Yeah, right up here, yeah.
Yeah.
Yeah, I figured it was. But look at, you know, a lot of stuff around. See, the Dan, to your point, the small dim stars, they do have some color.
Yep.
Yeah, to your point.
Your image, like so everybody, I mentioned imaging fast. Gary's taken that up to 20, literally. But what's happening with your system is that your stars are still pulling in all of the light from that mirror into one point. So if you're shooting even 2 or 3 minute subs, I'd be shocked that you have star color left. There's a cool trick that you can do to get some of it back, which is that you would shoot a bunch of short subs through each filter, and then you would use StarNet on your main image, and you would use StarNet on the star color image, and then you would use pixel math to add the stars transplanted from the short integrations into the main image, and that would give you star color back. But it takes a little bit of work. I haven't successfully pulled it off, other than I think one attempt once.
Well, that's a very, very good idea. Just like I'm going to be pestering Dave about what he was talking about there. Now I have to admit, you know, I'm using the analogy here of hunting for gold. I'm a gold miner, not a gold processor. So I love building telescopes and observatories. And when I'm done with it, I better darn well use it. So I haven't done nearly as much processing as I should, but I'm going to try and be a little bit more disciplined now and do that.
The other thing that helps, and you mentioned it yourself, Gary, is the arc sign stretch.
Yeah.
Yeah.
Dan put me onto that. So there you go. So, you know, this is great hearing from you guys, because, you know, we're all kind of giving ideas on what to do. Like that idea Dan just gave me is brilliant. And same thing with yours, Dave. I'll be talking to you about that.
Gary, what camera are you using for these?
This is my 16200 Moravian thing, which has turned out to be a great camera. I'm shooting it at -30 every night. And it works, and the images come out really clean. I'm very happy about that. The only thing that really bugs me about where I was at is the observatory walls were about a foot too low. So it turns out that my big telescopes act like, I've complained about this before, act like sails. So the whole thing is jiggling around in even the lightest breeze. So when I redid the walls, I raised them 1.5 feet. So the scope is well below the top of the walls now. So I can't wait to see what effect that has.
Great work, Gary.
Yeah, really wonderful stuff.
Really good work.
Thank you, thank you. So let me see your stuff.
Amazing. To say nothing of putting those old telescopes together that he did from just having a bunch of pieces. That's an amazing thing to do.
Well, how hard can it be, right?
I guess so.
Nutcase.
I'm going to share the screen now myself and try to show you stuff. Okay. So I wanted to talk a little bit about something that has captured my interest in looking at the galaxies that are labeled ARP. They're labeled ARP because this man, Halton ARP, created a catalog of what he called peculiar galaxies. And I thought they were really very interesting. And when I learned a bit about him, I found it even more interesting. He died at age 86, but he was an interesting character. And I have in front of me an obituary that was written by Dennis Overby. I don't know if you know that name, but Dennis Overby writes for, he's a correspondent for the New York Times, and he has written wonderful books about astronomy, including one called Lonely Hearts of the Cosmos, which if you get a chance to read it is really worth reading. Anyway, I just want to read a few things that Dennis said about Halton ARP. A provocative son of American astronomy, whose dogged insistence that astronomers had misread the distances to quasars cast doubt on the Big Bang theory of the universe and led to his exile from his peers and the telescopes that he loved. He died on December 28 in Munich. He was 86. He'd done most of his work in California, by the way, at Mount Wilson. ARP was an artist's son with a swashbuckling air. He was no friend of orthodoxy. He was a very skilled observer with regular access to a 200-inch telescope on Palomar Mountain. He sought out unusual galaxies and collected them in his Atlas of Peculiar Galaxies, showing them interacting and merging with loops, swirls, and streamers that reveal the diversity and beauty of nature. He found that galaxies with radically different redshifts and thus at vastly different distances from us often appeared connected by filaments and bridges of gas. This, he suggested, he said, that the redshift was not always an indication of distance, but could be caused by other unknown physics. The biggest redshifts belong to quasars, point-like objects that are presumably at the edge of the universe. Dr. Arp found, however, that they were often suspiciously close in the sky to relatively nearby spiral galaxies. This suggested to him that the quasars were not so far away at all, and that they might have shot out of nearby galaxies. If he was right, the whole picture of cosmic evolution given by the Big Bang of a universe that began to blaze in a blaze of fire and gas 14 billion years ago and slowly condensed into stars, galaxies, and creatures over the eons would have had to go out the window. Well, I haven't read all of this, but that'll give you a little bit of a flavor of who Arp was and what he did. None of what he proposed was unreasonable given the knowledge of the time, but it went squarely against what Hubble and some other people thought, and they kind of ostracized him. They ostracized him for two reasons. One, Hubble did not like the fact that Arp was making a big deal about peculiar galaxies, because Hubble thought all galaxies should fit into his tuning fork diagram that to categorize galaxies. So he didn't like that. And then, of course, the other thing is Hubble was famous for showing that the redshift showed that galaxies were far away, and Hubble was questioning that. Some of the other big names in physics, however, did support him, like Fred Hoyle at Cambridge, Geoffrey Burbage. These were people that believed in a steady state theory, and Halton Arp did too, of course. Anyway, I just wanted to tell you that that kind of background is what led me to look at some of these peculiar galaxies that he's talking about. I'm just going to show you a few of the ones that I've imaged, and I'm not going to show you too much about every one. I just want to go through them rather quickly. But the galaxy up on the left is ARP 29, and there's a nice cluster nearby. I took this a long time ago. This is what is commonly called the whale and the hockey stick in Canada. I don't know what people call it in other parts of the world, but it's ARP 281. And you can see the hockey stick has been greatly deformed by interactions with other galaxies like the whale. And the whale is a disturbed thing too. This is ARP 273, and this picture was taken at Alaska. One of the first times we ever got a chance to be up there and use it.
Wow.
And it's kind of an interesting galaxy with a spiral and then a tail coming out of it. This is M101, which is a familiar one to you, but Arp called it a peculiar galaxy, partly because of the strange shape of the spirals. Some of them go off straight and some of them really curl. Here's ARP 270. Some of these are pretty small. These are pictures I took a long time ago with a small refractor. This is the same one that ARP 214 that Dan had the beautiful picture of. This was in more standard colors, but so be it.
John actually got the companion there that I had to unfortunately miss out on. So
that's right.
Crazily nice shot.
I managed to squeeze the two together, and I think it's the companion that has actually helped to distort this ARP 214.
I think so, yeah.
And this is ARP 41. Another one of ARP 273. Here's ARP 9. Here's ARP 316. Sometimes the ARP numbers actually describe a cluster of galaxies. And this is one example. And you can see in this one, extreme distortion of a galaxy by another nearby one. Here's the one that Garry showed a much nicer version of this one, but this is M82, which is also called ARP 336. And here's a cluster that this is ARP 316. This is another one of my favorites. This is M51, which is another one of ARP's peculiar galaxies, and it is a bit peculiar. This one was done with Garry's telescope. This is probably my all-time favorite because this one, it's Stephan's quintet, but it's also called Hickson 41 group, named after Paul Hickson, who was a student in one of my classes back at the University of Alberta. This is ARP 84, which is called the heron, and it really looks like a heron bird about to eat a fish. And I think that's kind of neat. Again, it's extreme distortion of two galaxies that are interacting. Here's ARP 333, and here's a blow up of the main part of it, a process to give the color a little bit better. And here's ARP 270. And so that's a cluster of the ARP galaxies. And I wanted to show it in particular so that Dave Payne would understand why I asked him to do the tadpole galaxy when he said that he'd be willing to do something for me. And the tadpole galaxy is another one of these tiny little ones. A lot of the ones I showed you are really tiny in the sky. So they're not easy subjects, and it's not something you could easily make a wonderful picture of, but they're just so fascinating from the point of view that, you know, the fact that art focused on these things has resulted in us realizing that galaxies grow by mergers, something that Hubble just didn't understand or didn't want to know about. So I think that even though ARP's ideas about the Big Bang being wrong have not borne out as more evidence has come in, he still was a guy who thought hard about the issues, and he had really good ideas that were worth thinking about. So that's my contribution for tonight.
Very interesting, John. Very good.
And
Nice
I
collection.
think that John has understated the incredible difficulty to get images of those targets at all, much less images that look anywhere near as good as those.
No, you're not kidding.
It's that's just a incredible slideshow.
Yep. Yep.
Thank you.
How long
Well-
ago did he die?
Just a second, I should know that. 2014. Yeah, he died in he died. He was sort of like ostracized, so he ended up going to Germany, where he was welcomed into the one of the institutes there, and he lived in Munich and died in '86. Kind of a sad story in a way, because he deserved better than he got.
So Dave Payne, have you got the ant galaxy yet?
Yeah, I took a few, but the nights weren't great. So it's the galaxy's there. It's the long tail. So the tadpole has this long tail coming off of it. It's really faint. And I think if I had a clear night, I could be able to get it pretty good. But the nights I shot it on were hazy. One was a smoky, hazy night, and
Well, if I didn't think you were doing really good stuff, Dave, I wouldn't have given you that one to do.
There you
That's a
go.
challenge.
thanks.
Challenge.
That's true enough. True enough. And same thing for you, Brock. You're getting some pretty amazing images. Like, my goodness me, you guys.
Thanks. Although I should, has everyone done their main shots that people are going to show?
Yeah, go ahead, Brock.
Okay, I just wanted to put Gary's first light shot into perspective here. Let me show. This is my first shots with my new telescope on September 26th of last year. Can you guys see that?
Yeah.
It's the dumbbell.
It's a dumbbell. And then there's this, I did these both in one night. So a bunch of donuts. I look at the donut nebula.
Yeah, it's like a ring full of rings.
Yeah, there's a rings of rings.
There you go.
So this is
They're electrons. That's the main thing.
I think the day after this, I think I read about Batinov masks the day after this. And I think I'm
Of course,
ordering
Brock,
one
of
of
course
those.
you did that on purpose.
Yeah, right.
What?
The rings, the extra rings.
No, I don't think I did. Actually. I think I was just
Thank you.
trying my best.
The
With
sooner you
the,
move
It's how
over-
you learn.
Yeah.
It's how you learn.
That's how you.
Any other comments on the Astrophotos before we turn to Ken Atkinson, who's going to show us some, do some readings for us?
Yes, I have a comment.
Yes, Margie.
You mentioned the Horsehead Nebula.
Mhm.
Do you know who discovered the Horsehead Nebula?
Mr. Horsehead? No, I'm afraid not. I'm afraid I don't know what Margie. Who
Was it the Lone Ranger?
Williamina Fleming. Williamina Fleming in,
Really?
Right.
in 1888.
Wow. There you
Interesting.
go.
I didn't know that.
One
So,
of
Margie,
one
that's
of
a-
one of Pickering's computers.
Oh, one of it.
Mhm.
Very impressive. So how did you know that?
Interesting.
Well, I am putting together a presentation about women in astronomy.
Okay, there you go.
Cool.
but it wasn't
gonna do that at
cataloged till 1913.
Are you going to do that at the cafe?
I'm going to do it for the DAO on September 7th.
Oh, okay, good. That
Yeah.
sounds wonderful.
Good deal, good deal. We should do this more often because if we can share techniques with each other, that really is going to help us all a lot.
I think so. I think it's good to get this. This gets us back a little bit to what happened when I first started. We didn't have all the equipment we have now, but there was an incredibly supportive community that was helping people that wanted to get going.
Yeah.
And I think that's the way people get to the stage where they're doing really fine work.
Yeah.
You have to get some help along the way because there's so much to learn. None of
Yeah.
us can do it all.
You said it. You said it.
Mhm.
So, Ken, are you still with us? Yeah, I see Ken there. You want to do your thing now?
Okay, well, I won't dodge her into other websites. So weather map, you can easily follow that up. It's very handy. I've got a lot of information from Nature, which has, well, you can spend money and subscribe, but it covers obviously a lot more than astronomy, but it does often hit astronomical topics. Away from astronomy, I was surprised to discover that the human genome was not actually unraveled 20 years ago. And they handed out a Nobel Prize, my goodness. 20 years ago, they unraveled all but 20%. The 20% was too difficult, so they called it junk, collected the Nobel Prize. Only this year has somebody finally unraveled the last 20%. And now we have what's called telomere to telomere reading of the human genome.
Mhm.
And I also discovered why telomeres matter. They're the things that hold the double strand together. Lose your telomeres, your DNA splits apart. Not good. Okay. Anyway, there's other stuff. Another example from an earlier issue was an astronomical thing about a highly magnetized and rapidly rotating white dwarf as small as the moon, a star, not a neutron star, but a white dwarf. Spins.
And your picture isn't changing. We're still just seeing.
Well, that's what I'm talking about. Down at the bottom, there's something called magnetized rapidly.
Okay, okay.
Yes. Okay. So a star that spins in 7 minutes. Try sketching that. A magnetic field of 600 to 900 million Gauss. I think that's big. Don't go near there with nails in your pocket.
On the wrong side of you, anyhow.
Yeah. All right. So carrying on, can you see the next one? This is where John mistook my understanding of reading. These are books that I've been reading. I mentioned this a couple of years ago, Birth of a Theorem by Cédric Vianney, a French mathematician. And mathematics, of course, supports astronomy. How could you do it otherwise? So I found it extremely interesting as the sort of working experience of a live mathematician. He's still around. He got quite involved in politics. And now he's back into mathematics, but definitely a good read if you want to see how mathematicians think. I had no idea they think. A new one for me is an American writer, Carl Jurassic, and he's no longer alive, but he was a chemist and he knows the scientific world, and he developed basically the oral contraceptive. So what's the interest there? He's written a number of books. The one I've been reading is called Cantor's Dilemma. And again, it's an insight into a scientist's life. And he's a serious scientist. He did not win the Nobel, but he knew lots of Nobel winners, I believe. And so this is a fictional story. And it gives, at least gave me the feeling that I could really understand what the pressures are like to be in a high demand research environment. Really interesting. He's written other ones, Newton's Darkness. I haven't read that, but I was surprised to discover that Newton was not such a nice guy. Remote, lonely, secretive, introverted, melancholic, humorless, puritanical, cruel, vindictive, and worst of all, unforgiving. My goodness. So anyway.
Poor Hook.
I don't know what he.
Hook's Law was
you
spring.
think Hook could look after himself? I don't. I don't know what the squabble was there. I know Leibniz. They had a squabble over many things, but in fact, I think there was threats of lawsuits from England towards Germany. Leibniz backed off, but Leibniz is the guy who gave us calculus we use now. Newton developed calculus, but he did it in the form of infinite series. I mean, really, or, you know, take a limit. You get really tired. There's a limit to limits.
Well, he burned all of Hook's research when Hook died.
He burned them.
He burned his university notes.
Oh my goodness. Yeah.
And sort of claimed a bunch of Hook's stuff for himself. But there were other copies, wow. and in the end, Hook was vindicated. But it.
Oh, that's interesting. I had no idea. Yeah, there is a biography of Newton. I have not read it, by Walter Isaacson. So it's on my shelf. So I'm going to read it because it sounds like he's an interesting character, even if I wouldn't necessarily like him.
When Newton was the master of the mint, he took great joy in tracking down counterfeiters and made a point of attending their hangings. He was not a socially acceptable person, I think.
Oh my goodness, yeah. And occasionally he went off the rails with science. He tried to find ways of transmuting this and that into gold. Never quite worked. And there was a story about how he came to be a professor of physics at Cambridge, I believe. Initially, it was not possible because Cambridge was essentially a place to train Anglican priests. And he became trained as an Anglican priest, but he had issues with the dogma, and it had to do with the triune God. Is it one God with three faces, or three separate, like a trio, triumvirate? And he was on the wrong side of the argument, so they would not accept him as professor. But because he'd done so much for the king, like provided artillery tables, the king said, he can be professor. So there.
He was one of the early Unitarians.
I didn't. It sounds like maybe, yeah. The last book it's quite interesting. It's a history book, but it touches on Einstein. So I thought, that's a bit of science, a bit of astronomy. And it's a really interesting book. There was a German who is combined Irish and German descent. Mother was Irish, I believe, and father was German. So he knew both worlds, and he was quite well off. And he basically worked as a diplomat, and he knew all of the major figures in Germany primarily, and often in other countries as well. So he's totally new to me. He was mentioned in a book by Margaret Macmillan, The War That Ended Peace. Excellent book. So I looked him up, Harry Clemens Ulrich Graf von Kassler. Graf is a count. And his diaries are in two parts, one leading up to the end of the First World War, and then the last one from 1918 to I think 1933. Just, I won't read the whole thing. No readings, just brief little mentions. Starts off 13th, well, this is page 150, so it's just this excerpt. Starts off 13th of February, 1922. The Pope's coronation. He was there. I mean, this shows that he was pretty well connected. And he got into St. Peter's, bit of a scramble, fine. Then he went back from Italy to Germany and went through the Brenner Pass. I was there on my little bicycle. And his experience was different than mine. He went to a beastly inn mentioned by Goethe. It was full of noisy Italians, railway officials who drank more than was good for them. The upshot was a scuffle with the landlord, whom they knocked down with chairs. What a kind of a vital life. I mean, awfully violent, but and the explanation was, well, they're Italians, we're Germans, that's all. Bingo. And gets back to Germany, and he has a meeting with Rathenau. I believe he was the foreign affairs minister in the Weimar Republic. So he's pretty well connected. I can't read all this. I find it really interesting. The interest is it's a personal account, and he's describing in his diary, I mean, it's unexpurgated. He's describing people that he met and how he found them. So it mentions here dining with the Einsteins. Is my mouse visible?
Yep.
Oh, okay. So because I wasn't sure if I was pointing anything out. Just before he met with Einstein, there's this paragraph that caught my attention. In his conversation with Rathenau, he says, "We cannot promise the French désarmement moral," because there was a big disarmament push after the First World War. And so here's Rathenau resisting it. Why? Because our German entire youth is moving in precisely the opposite direction, towards the worst, most obdurately reactionary outlook. So I find that fascinating. Like 4 years after the war ends, and there's this angry reaction, like reactionary, and this isn't the part of the youth. That's very fascinating. Anyway, he dines with the Einsteins, a quiet, attractive apartment in Berlin West, Haberlandstraße. Rather too much food in a grand style, to which this really lovable, almost still childlike couple lent an air of naivete. Guests included the immensely rich couple, the Mendelssohns, Warburg, Bernhard, Dernburg, as shabbily dressed as ever. I like the phrase. I mean, I have no idea who Dernburg was, but just that mention that he was shabbily dressed. That's kind of cool. Anyway, see, he's meeting, this is Einstein. He's dining with, he's invited a really rich man, couple. Never heard of him before. Mendelssohn, of course, the musician. So just in one evening, it sounds like, Einstein reached out. He had a lot of contacts, really interesting. Einstein talked about their reception in the United States. Einstein gave a slightly ironic, skeptical twist by claiming that he cannot make out why people are so interested in his theories. His wife told me how he kept on saying to her that he felt like a cheat, a confidence trickster who was failing to give them whatever they hoped for. And that's kind of cool. And a sketch of Einstein by someone named Strink, who I have no idea. and so forth and so on. So the last bit is purely by chance, about 3 months BC, before Corona, I was in Berlin and I happened to be walking around this area where Einstein lived. The little red spot is where Einstein's house was located. And I was walked around the Bayerischer Platz. And I noticed it because there are all these names typical of Munich. Bavarian Place, Landshuter Straße, there's a city called Landshut, Münchner Straße. So I thought, oh, that's interesting. I'll take pictures and send them to my friends in Bavaria. I had no idea Einstein's house was in the area. But there's an interesting anecdote. I guess you can read it. An anecdote of Einstein involves him traveling home from a social engagement in a taxi and proclaiming to the bewildered driver that he had forgotten where he lived. Asking the taxi driver, who did not recognize him, if he knew where Albert Einstein lived, he was told, oh, of course, everyone around here knows where he lives. To which Einstein replied, good, take me there then. I love it. Yeah. And so just to show you, I really was there. This is how the Bayerischer Platz looks now. You can see the sign, Bayerischer Platz. And not, kind of ordinary really, except kind of a pretty little pond, ornamental goldfish in it, I think. Very middle class, all these cars and low-rise apartments, a sculpture there. That's a nice touch. Yeah. Anyway, so there, I was there, but I never knew that I could have walked another 100 meters and seen his house. Nevertheless, thanks to the web, I have a picture of the address where he lived. This looks like the building where he lived, but the actual building was totally smashed in the war. But they rebuilt a building pretty much in the same style. And so Einstein lived on the top floor corner. So not a big apartment, but big enough to have guests over. Most of the time, apparently, he lived in a summer house out south of Potsdam, not far from a little lake about the size of Thetis Lake, perhaps, close enough that he could walk down and take his boat out on the lake. Yeah. So he lived there for a number of years. And the last bit is a commemoration in front of his former house. I'll saddle you with some German. Hier wohnte in dem früheren zerstörten Haus von 1918 bis 1933 Albert Einstein, Physiker und Nobelpreisträger, geboren 1879, gestorben 1955. So the content is pretty clear. But I like the mention of the guests that he had. And this would be, over time, Charlie Chaplin, Franz Kafka, Max Liebermann, I can't place him, Heinrich Mann, Lisa Meitner, sort of have an idea, Karl von Ossietzky, Max Planck, who basically sponsored him when Einstein wrote his first papers in 1905. He was not known. And he thought, if I send it into, a science magazine, Zeitschrift für Physik, probably, they will probably not accept it because they've never heard of me. So Max Planck, he sent it off to Planck, and Planck said, this is good. And he sent it on to the Zeitschrift, and it was published. But Planck was basically a big supporter of his. And Rabindranath Tagore, who I do have an idea was the writer, perhaps. Anyway, what's striking here is that Einstein knew quite a big literary community, Kafka, Mann, and I think Tagore was an author. And Charlie Chaplin just, that shows a sense of humor. What the heck? So anyway, so those were my explorations in lieu of having a nice camera. So that's it.
Good.
Well, thanks very much, Ken. That was great.
Thank you.
Whoa. Something crashed in my place. Wendy says it's nothing. I hope that she's right. Okay, does anyone else have anything they want to add at the end of the session here? If not, I want to thank everyone who contributed. I found it interesting tonight. I hope the rest of you did too.
Yep. Thanks for the advice.
Okay. Good night, everybody.
Bye.